Hello students, today we are going to discuss about amplitude modulators under the topic amplitude modulation in unit 1, and the course outcome of first unit is distinguish various AM communication systems. So AM modulation circuits, based on the location in the transmitter, it is classified as low level AM modulator, high level AM modulator. Difference between low level and high level AM modulator. Low level AM modulator modulation takes place prior to the final stage of the transmitter. Less modulating signal power is required. Whereas in high level AM modulator, modulation takes place in the final element of the final stage of transmitter. More modulating signal power is required for high level AM modulator. So these are all the two classifications of AM modulators based on the signal power and modulations place. Generation of AM, that is double sideband with full carrier modulators. Again, it is classified into two types: linear modulator and non-linear modulator. So linear modulators, it is otherwise called as large signal modulator or high level modulator. Non-linear modulators are called as small signal modulator or low level modulation. So first one is linear modulator. So from the name itself, the output of the modulator is going to be varied linearly according to the input signal. So that is why it is called as linear modulator. The devices are operated in the linear region of its transfer characteristic, that is VI characteristics. So linear modulators are also divided into two types. One is transistor modulator and another one is switching modulators. Today we will discuss about device switching modulator. So this is the block diagram of the circuit diagram of switching modulator. Here we are giving the modulating signal as well as the carrier signal in the same line. So here we have one diode, and this acts as a band pass filter. So the function of this diode is, whenever the input signal is entered at this particular switch, when it is greater than the voltage level, threshold level, the switch is going to be on. The diode starts conducting for positive values when it is forward biased. Whenever it is reverse biased, during the negative half cycle, the switch is closed and there won't be no current conduction. So positive half cycles after the modulation, the signal is going to be transmitted. So this band pass filter which allows only the required band of frequency. This is the basic concept of switching modulator. So we can write the output voltage of the modulating signal when the output voltage is absent. Vc of t is equal to Vc into cos omega Ct. So we can write the output voltage across these two terminals as Vc cos omega Ct, that is your carrier signal, plus Vm cos omega Mt into cos omega Ct. So if you are going to take Vc cos omega Ct outside, so this leads to Vc plus cos omega Ct Vm into cos omega Mt. So this is the required equation for linear modulator. That is, it is a combination of carrier signal. The sidebands are there, two sidebands. When you expand this equation, we will get cos A, cos B. So upper sideband and lower sideband will be taken from this side, and Vc cos omega Ct, which represents your carrier frequency. So we got the modulating signal. The non-linear modulators. So these modulators are operated in a non-linear region. These are used in low level modulation. So low level modulation means a signal level, energy level is low. The types of non-linear modulators are square law modulator, product modulator, balanced modulator. First we will discuss about low level AM modulator. Class A amplifier can perform amplitude modulation. This is Class A amplifier which performs low level AM modulator. Amplifier must have two inputs. One is carrier input signal, another one is modulating signal. So here the modulating signal is applied at the emitter of the circuit, and the modulating carrier signal is applied at the base of the terminal. So the modulation takes place here, and we can derive the modulated waveform at this level. So this is the waveforms which represents modulating signal, collector voltage. According to the collector output voltage, we will get the AM envelope at the output side. So mathematically we can explain this as the voltage gain for emitter modulator. This circuit is expressed as AV is equal to AQ into 1 plus M sin 2 pi FMT, where AV is nothing but amplifier voltage gain with modulation. AQ is amplifier quotient, that is without modulation voltage gain. So this is after modulation, the voltage gain is represented as AV. AQ is again the voltage gain but without modulation. We know that sin 2 pi FMT varies between plus 1 to minus 1. So AV is equal to, when you substitute these values, we will get AV as AQ into 1 plus or minus M. So AV max is equal to twice the AQ when the modulation index is 0. Similarly, AV minimum is equal to 0 when M is equal to minus 1 in this above equation. So the modulating signal drives the circuit into both saturation as well as cutoff, thus producing the nonlinear amplification necessary for modulation to occur. So the collector waveform includes the carrier and upper and lower side frequencies as well as the component at the modulating signal frequency from the waveform. So thus we produce a symmetrical AM envelope at the output side. So the advantages of low level modulation: less modulating signal power is required to obtain the high percentage modulation, and another advantage is modulating signal is produced based on the modulating circuit. As we told, it is a low power applications only, we can go for non-linear modulator or low level modulator. Disadvantage of this low level modulator is amplifier following modulator stage, it must be linear. At high operating power, linear amplifiers are very inefficient. So these are all the disadvantages of low level modulator. So that is why we are moving to medium power AM modulator or high power AM modulator. So the difference between low level and high level modulators is, here we are applying the modulating signal at the power amplifier, which is going to improve the energy level of modulating signal before modulation. Okay, then here in the RF tray we are applying the carrier signal at the base terminal, and this will act as a modulator. Your modulating signal and carrier signal is going to be added, so we will get modulated output across this terminal. So the class C amplifier is used. It operates in the non-linear region. This is known as collector modulator because modulating signal is applied to the collector of the circuit. When the amplitude of the carrier exceeds the barrier potential 0.7, your Q1 turns on and the collector current start flowing. When the carrier voltage drop below 0.7, the Q1 is in off condition, then the collector current cases reduces. The corresponding current and voltage waveforms are shown in the next slide. When the modulating signal is applied, it adds up with the carrier signal and gets emitted from collector output. So advantages of high level modulators compared to low level: there is no constraint of linear operation on amplifiers preceding the modulator stage. So power efficiency is good. Disadvantage is high modulating power is required. Final modulating signal amplifier has to supply all the side